Next, we want to find the Maclaurin series for f of x equals 1 plus x to the kth power, where k is a real number. So this is like a binomial to the k power. So what we need is we need to know f of x when x equals 0, we have 1 to the kth power is 1. The first derivative is k times 1 plus x to the k minus 1. Setting x equal to 0, then we're going to just get k. Second derivative gives us k times k minus 1, 1 plus x to the k minus 2. So that's k times k minus 1. Third derivative gives us k times k minus 1 times k minus 2 times 1 plus x to the k minus 3. So setting x equal to 0 gives us k times k minus 1 times k minus 2. I think we have enough to form a pattern here. So the nth derivative notice we've got 1, 2, 3 of those. So we want n of them here. So k minus 1, k minus 2, dot, 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 k minus n. Is that right? Would that give us the right number of them? Well, we need one less than that because k minus 0 is the first one. So if there's n of these, the last one should be k minus n plus 1. Okay, so now there are n of those. N of those. And then times 1 plus x to the k minus n of these. So third derivative here matches the third here. Nth derivative here matches the n here. Third here, second there, and negative n plus 1 there. Okay? So then the kth, evaluating it at x equals 0 gives us just that coefficient k minus 1, dot, 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 k minus n plus 1 there. All right, so what we can do is we can write our series now, and the series is the sum. Well, suppose we could write it out first. So we've got k, we've got 1 plus k x, there's our 0 factorial and our 1 factorial, k times k minus 1, x squared, 2 factorial, k times k minus 1 times k minus 2, x cubed, and here's our 3 factorial, and so on. So let's try to write this as a sum. What do we have? We have this nth term, k times k minus 1, dot, 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 k minus n plus 1, x to the n, all over n factorial, going from 0 to infinity. Now, if you've had some statistics previously, you may have said, you know, this right here looks familiar. This is called the binomial coefficient, or sometimes we'll write it k choose n, or sometimes we call it a combination. When these are integers, or the number of ways to choose n things out of k total things, something like that. But you will also notice if this is if k and n, well, of course n is an integer, but if k is a positive integer, these are also the coefficients of the Pascal's triangle. Right? These are the binomial coefficients. So we write this sum as the sum from 0 to infinity of k choose n times x to the nth power. And this is called the binomial series. And that's our expansion of it. Okay, so we want to be able to use this to work a problem. So here's the question. Find the Maclaurin series for, how about something simple? 1 over 1 minus x under the square root. So the key is, can we write this as 1 plus x to the k power? And the answer is yes. We could write this as 1 plus a negative x here to the negative 1/2 power. So if I look back at my formula there, then this says our expansion is, let's see if I could get them both on the screen there, the sum of parentheses, what's our k? Our k is a negative 1/2. Then we have our n right there. Then we have a negative x to the nth power. So that's our expansion. If you prefer, we could rewrite it so that it's got that alternating sign and write negative 1 to the n, negative 1/2, choose n, x to the n. And that's it. If we wanted, we could use our calculator, we could use whatever tools we have to evaluate this and expand it, but that's tedious. We could write out those terms. Again, that's tedious, and I don't really care to do that. I just want to find the expansion, and that is the expansion. So we're done with it.